Okay, so we are online now. Hello, everybody. Thanks. Welcome to this office hour. So the go out, hangout or something. I think this is the only approach to contact us. So for this week, I think you're supposed to finish um, the parser issues. LL1 parser, the first, how to calculate the first and follow set, which is to evaluate whether the parser is LL1 or LL2, or which is also impact stuff for like writing a parser code. But yeah, but actually in the project we used the Lexus. But if you like using a handwrite a parser, you definitely need these informations, the first follow sets, to build an effective parser. So from next week, actually, by this week, you also should have finished the things about the semantic analysis, especially how to build semantic trees, the AST trees, and how to validate the type information, whether there is semantic errors on the code by checking the trees and some semantic rules. So for the next week, I think you're supposed to working on the IR code generation, and for this, for the materials covered in this week and next week, which are all the important materials for the project, is the part two of the project, which is very like the most important thing in the project. And hopefully you are doing well on these materials. So, Yuhong, do I have anything to announce?
Yep. So for the homework, I finished the gradings, and I'll be release the grades after the office hour. Or yeah, actually, I can release it now, I think.
Oh, okay. I forgot to mention that the professor is busy with something else, so he cannot join us today. So today we just have Yuhong and I online, and possibly, yeah, we will try our best to answer your questions. And if we cannot answer questions, we will pass it to professor, and maybe he can answer it in next week, some other times. So yeah. And on the Piazza, Galen has two questions. The first question is about whether we need to worry about indirect left recursion for project one. And my answer to this question is yes. So for project one, especially for project two, I think simply doing the left recursing simply could be not enough. So generally, I would suggest you to like rewrite the grammar by yourself. I think some of you have figured it out. So I have already given you some examples. So for handling the left regression, one thing is merge the two grammars into one, and to reduce the common path, and to fix the common path, and make the different rules for the rest of the part of the of the grammar. I think I have like posted some examples with some discussions or with some like threads. They could find it through in the Piazza about this simple idea and technique. And as for the first thesis, and his second question is whether you need to perform the left factoring by finding the first thesis for each production, and then transferring those productions to create a disjoint first thesis. I think it is, if we do it, I think it is an interchangeable way. I mean, you need to first do the left factoring, and then calculating the first and the follow sets to check whether the grammar is LL1 or not. If not, you need to do the left factoring again, and then to compute the first and the follow sets again to check whether the grammar is already approached the LL1. So you need to repeatedly doing such kinds of work. And I think the first test and the follow test tell you, especially where it's like which grammars are not LL1. So that is helpful information. And I don't think you need to do the first the follow set firstly, and then do the left factoring. That is my personal experience, of course.
Yeah, I think Chao's answer is pretty is correct for the second question. And another thing that I want to mention is for the left factoring thing, people usually, so some of the rules are like in the form, I say that they were concatenated into one rules. People usually unroll it to find out the things that need to be left or factor out. Yeah, it's just some techniques for left factoring operation. If you, yeah, it's just some techniques. If you have further question about the left factoring, you can post it on Piazza, and we will try to answer the questions in specific to the concrete examples.
Okay. So Yuhong, can you answer the question from Daniel? Hey, Yuhong.
What's that?
Can you answer the question from Daniel?
Oh, sure.
It's about the attribute grammars.
Yeah. So the attribute grammars is functional. I think what Professor meant is it is used for how would I say this? It's not simply about the syntax. It's more like the semantic meanings. For example, when you're doing the binary operations or some other arithmetic operations, you want to make sure that the integers will be added to integers. If it's like, I cannot remember the exact rules. If it's integer plus a floating point thing, so some rules will make sure that this should not be happened in the language. If that happens, the attribute grammar actually works to do this kind of semantic analyze to find it out. Yeah, why it's important? It's just the if you want to find these kind of errors during the semantic analyzing step, you have to use this kind of attribute grammars. Not have to, it's just one way to do it. And this is what Professor mentioned in class. So yeah, I think it's pretty important, right?
Yes, actually, the attribute grammar, I think one of the important perspectives is the type checking. So we don't, I don't know whether you are familiar with C language or not. If like for C languages, if you want to do addition from like integer to a string or to a character actually, so it will generate some errors. So these errors are actually detected by the attribute grammar. So for each kind of restrictions, like the type checking, we needed to set up an attribute rule for each node in the AST tree. So if there is more than like construction restrictions, like if whether we can do something for the like the member like like get a member from the structure from a structured data structure. So if the target is a pointer, you need a different grammars. So based on this, actually, you need to set up another set of attribute rules for each node. So generally, depends on the complexity of the language. You need to set up several attribute rules, and some of the rules are related to the value, like evaluation. Some of the rules are related to the how do I say, to the type to some like semantic information actually. So that is why I say so each set of rule has different function, like functionality. One is for type checking, the other is for validating whether the access is correct way. It is using the pointer, use an arrow for the like pointer. So I think that this is general idea. What is processor mentioned? The attribute grammar is function grammar. Hey, Yuho. Can you briefly describe something about the homework, how it looks like for like after grading, for grading? Yeah.
Sure. So from the homework, there are several commonly seen problems. First is about the question 1, which was rewrite the grammars that accepts multiple declarative statements and multiple assignment statements. So one common question is some students forget to include the now case, which terminates this kind of multiple statements. For example, the declarative statements should yield to one declare statement and another declarative statements list, and this declarative statement lists should also be derived to a null case, which will terminate this list. So this is commonly seen question, and another is for the question 4. Some people think the first rule, which was LK, says that let me find it out. The question asks if the so in this question, k is a fixed positive integer. I think so some students who did it wrong is because they didn't really understand what the question asked. The question asked some specific languages L at which k is a given integer. Although k could be varied, but for this language, k is k. So actually, it is a regular language, and the regular expression for this is you could either write use the OR operator to concatenate from epsilon to k numbers of a's, or you can just write a to the k as a regular expression. Let me think if there is other commonly appeared questions. And okay, so for the question two, there is one question two part 2. The question was the language W, where W is any strings not in B star, A star that can be derived from the vocabulary A and B. So B star and A star, because the regular expression star means 0 or more occurrence of this character. So B star and A star will include only strings contains only A's, and this is the case that most students missed. So some of the state machine, the DFA provided for the answer will accept strings contains only A's. So yeah, which will accept the wrong string. And for question 2, part 3, it's also, I think it's some misunderstanding problems, because the question asked string W is any strings that can be derived from the alphabet 0 and 1 except 111. The question asked so 111 means this specific string that contains 3 consecutive ones. So no more characters in these strings. So the only strings that will be rejected is this one. So some of the answers will reject any strings that contains 3 consecutive ones as a substring. Yeah, I only reduced 1 point for these kind of answers. I think it's not a huge problem about the knowledge base. It's just some misunderstanding of this question. Yep. And for question 3, there is no. So if I think it's a pretty easy question if you understand this. I actually don't know how to read this algorithm's name. It's Brozowski's algorithm. If you know it, then it's an easy question. Someone who did it wrong, it's just because they either missed some, they either did something wrong during the reverse step. Maybe one transition was not reversed, or some other kind of subtle mistakes caused their final minimum DFA is not correct. So I checked all the steps to see which part was the mistake occurs, and I leave comments about those questions for everybody, so they can check it out to try to understand this algorithm and what kind of mistakes they have made, so they can have a better understanding of this algorithm. yeah, that's all about the homework.
Okay, thanks.
Hi, Paul and Dipendra. So Professor is not here today. So if you have any questions, you can just ask us and we will try our best to answer your questions.
Okay, thank you. So I was going through the attribute grammar. So I would like to know whether those grammar can be specified in the ANGLR, or those are just for the parsing purpose, the semantic analysis. So how it is different from the normal grammar that we defined in ANGLR?
Okay, you can
first. You can answer this question.
No, yeah, maybe like more. Just do the project. I think you're more familiar.
Okay, so yeah, there is no way to specify any attribute grammars for Antler for them to do it for you. You have to. What you can do is you take a paper and write down those attribute grammars, then implement it through the Antler, either web visitor or worker. At the step when you walk through the parsing trees. So yeah, I'm not sure if you have watched the video that talk about the attribute grammars from Udacity or not. So it's basically a pre-order traversal and the post-order traversal. The attribute were like finish it during these two kind of traversal steps, and you have to implement it into your own the tree walker.
Okay, so yeah, now I got it, I think. So the attributes are basically nothing but the node properties that we can get from the parser, right? So we just traverse to the AST and figure it out how to evaluate, right? That's the point of having this algorithm. Is that correct?
Yep.
Okay, thank you.
Actually, when they do the traverse, do they need to hacking the class to obtain some variables indicating the attribute? Like, for example, the value type.
So, what do you mean by have the class?
No, I mean not have class. I mean hacking the class, because like in the Antler, the path tree is represented by a class, right? Each node is represented by a class object, right?
Yep.
So when they're attaching some attribute to the node, do they need to hacking the object, the class object, by adding some more variables?
I think it depends on how they want to actually implement it. So what I did for this project is let me think. So for every entry I had another data structure that stores all the type information. Every time I enter a node, I will consult that data structure for the types that I need. Yep. But yeah, I think you are right. You can do that to have the node contains these kind of attribute informations, but I'm not sure if that would be an easy way or not.
Okay.
Okay. I just have a slight question. It's concerning the checkpoint. When do you think we'll get our comments so we know where we've gone wrong and we make the necessary corrections?
I will try my best to finish this weekend. I think no later than next Wednesday.
Okay.
So also for the project, right, is it okay to use the unit test in the form of test rather than giving the actual executable example?
Yes, you can use any tools, but when like submitting, just our basic requirement is when you're submitting your code and the report in the final due date, it should be including a makefile to tell us how to run your code, so we don't need to do any configurations. So because based on the previous classes, some of them submitted a code that is compatible on their machines, but we cannot compile it on our virtual machines. So it will like waste of some time because they have maybe have some specific stuff or something they didn't finish it in time, but they just submitted something wrong. So in this case, I would suggest to you to create a makefile can compile it successfully, and try it on a new the virtual machine to make sure it is compatible.
Okay.
If we made some changes.
I use Java and Maven. So Maven by default requests the internet connectivity to download the jars. So
yeah,
that's the problem.
That is fine.
That is fine. Okay.
No, we have the internet, so that is fine.
Okay. Yeah. But before submitting the project, the final project, I'll make sure it will run within the image virtual machine.
Mm-hmm. Another thing is about the testing file. Actually, we provided some testing file, but they are simple. So maybe cannot cover every cases. So in our final grading, I was using some test files from the samples are given to you, and I would also create some very simple test files to evaluating the symmetric rules or your parsers that could be not provided to you. So I would suggest you to think about the requirements and generate some test files based on by yourself to test your code to actually to check whether for some grammar errors where they can detect it, and for some semantic errors where they can detect it and print the messages in a correct way. So I'm trying to writing a simple virtual machine to evaluate to execute your IR code to check whether the code will generate the same outputs as expected. So yeah, I think that is all of the idea to mention to you. Actually, this is the first for this semester. This is the first time to do such kind of things because we're trying to build some automatic grading system. So to make the grading as easier as possible and also as fair as possible. So.
One more thing, the project has some example printf function, right? Print function.
So, yes, it can.
Yeah, is that the function we just built in provide, or we should provide as a built-in, or is it kind of like something kind of library you can include? So So I didn't get that from the project description. So for example,
Okay.
if you include the header, then only the function will be available, and that function implementation will be in the library. But it looks like in this case, the function itself is a part of the compiler, right?
In terms of your question, it's not. In terms of the project, actually, the document has some information about the built-in functions. So you don't need to care about this function, about how printed works. So when you're generating like IR code, when you meet a print statement in the Tiger program, you simply just generate a call function to the print. So there are, I think the document has indicated that some of the functions are the built-in functions. But actually, this built-in functions is not implemented by the compiler. I mean, in terms of your question. So when you're testing, it's actually currently it is not related to you guys. Do not need to concern much about it because it just simply generate a call statement to the function. But when you're running it in the MIPS for the second part of the project, which is try to generating the machine code, the MIPS code, I think the MIPS providing some functions, providing some libraries for this. So you also don't need worry about this. So, and yeah, but if you want, you can like writing some MIPS assembly code to implement such kinds of print function. That is not a very difficult. So I think yeah, that is all. Okay. You can using either the software provided by MIPS or provide just to implement. Actually, yeah, for the test code, I can guarantee that the only function I would use is the print an integer. Maybe I don't think I will print anything in a string, especially print an integer. So this is the only external function you would care about.
Okay, thank you.
Okay, mine is just a request. I just have seen the homework 1. I missed out on question 3. Is it okay I send you a message on Piazza? You explained to me precisely where I went wrong.
I mean, for homework 1?
Yeah.
Yeah, okay. You can send me the request.
Okay.
Okay, since there is no more questions, so I'll terminate the current office hour a little bit earlier. See you next week.
See you.
Bye, Yuho.
Bye.